dear viewers, and good morning, my dear students. I hope all of you are safe at home. Last time we have started electric charges and fields. In that we have finished electric charge concept. And today let's go one more concept in the electric charges and fields, that is Coulomb's law. So generally mass causes the gravitational force between any two masses, and pole strength causes the magnetic force between any two poles for pole strengths of a magnet. And similarly, an electric charge causes the electric force between any two charges. Therefore, when you have taken two charges in medium or in any free space, then one charge applies the force on other charge and other charge experiencing the force from one charge. So how to find out the magnitude of the force? Means what? How much it is. How much force acting between two charges. That magnitude can be calculated by using Coulomb's law. Therefore, Coulomb's law is mostly useful to find out the magnitude of electric force between any two charges. Now, the magnitude of electric force between any two charges depends on two important factors. One first important factor is that is system of units used. Means what? So, to find out the electric force between two charges, what unit you are using, either SI unit or CGS unit. Means charge you are expressing in SI unit or CGS unit, and force you are expressing in CGS unit or SI unit, and the distance you are expressing in CGS unit or SI unit. Therefore not. So the magnitude of the force depends upon the first factor, that is system of units. Means if you use SI unit, that magnitude of the force is different. If you use CGS unit, that is also different. Now, so second one, that is the medium between the two charges. For example, if the two charges are present, now this is completely air. Now in this air, if two charges are present, now what is the force between them? That is different. If the same two charges, first charge magnitude is the same, second charge magnitude is the same, distance between them is also same. If the two charges are keep inside any other medium like water or alcoholic material or kerosene or petroleum, etc., then automatically the magnitude changes. Means what? So now the force, the magnitude of the electric force between any two charges also depends upon the medium between the two charges also. Therefore, the magnitude of electric force depends on two important parameters. One important parameter is the system of units, and other one is the medium between the two charges. Next, okay, so how to find out this magnitude? That is given by the Coulomb's law. According to this Coulomb's law, first of all, let us express all are in SI unit. Means force, charge, distance, all are in SI unit. Then, so in free space, once again what I told you, if you are expressing all quantities in SI unit, and if the two charges are present in the medium in free space, then the force between them is given by F naught is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Here you see this diagram. Therefore here, so here first charge and second charge, the distance between them is R. These two charges are present in vacuum or air or free space, then this is the force between them. And here, if these same two charges are present in any medium, this is the medium you see here. So means what? It may be, this may be water or kerosene or any other media, then the force between them is given by, so this is the force between them, F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. So all of you viewers, you should observe that here 1 by 4 pi epsilon naught I have taken. Here in medium I have taken 1 by 4 pi epsilon. Here, so 1 by 4 pi epsilon naught value means what? This constant value, that is 9 into 10 power 9 Newton per meter square, and here this epsilon is called as the permittivity of the free space, and its value is 8.85 into 10 power minus 12 Coulomb square per Newton meter square. So this is constant value or fixed value. Means what? For free space, this is a fixed value. And next, here 1 by 4 pi epsilon value is different for a different medium. Means what? If this medium is water, therefore 1 by 4 pi epsilon value is different. And if this medium is the kerosene, then this value 1 by 4 pi epsilon value is different. Therefore, for a different media, this 1 by 4 pi epsilon value is different. Means what? When this value is different, therefore the force of attraction or force of repulsion between any two charges is different from one medium to other medium. Therefore here this epsilon is there, no, epsilon is called permittivity of medium, and here epsilon naught is called permittivity of the free space. Similarly, this epsilon value is different for different media. So now here this is the, what is that, all these are explanation only when we are expression in SI units, okay, and therefore now this is the 1 by 4 pi, and please be careful about this information, and this is very very important. Sometimes this value they will give in the problem also, not need to worry. Now what is the permittivity actually? Permittivity is property of a medium that changes the electric force between two charges. For example, consider two charges. The electric force between them is 20 Newton when those two charges are in vacuum or in free space or in air. Now same two charges, without changing their magnitudes, without changing the distance between them, just to take them inside the water, automatically you can observe one point that so the force reduces, means force decreases. So when they are in vacuum, the force is 20 Newton. When they are kept in any medium, the force, let us consider 15 Newton, means 5 Newton is decreased. Who is responsible for this decrease in the electric force? Means you are not changing the first charge value, second charge value, you are not changing the distance between them. What you changed? Just medium change. Due to the medium change, the electric force decreases. So the property of that material or the property of that medium which reduces the electric force is called as, so that is permittivity. First point. Now, so relative permittivity. What is the relative permittivity? The ratio between permittivity of the medium to the permittivity of the free space. Order is very very important. It is epsilon by epsilon naught, not epsilon naught by epsilon. Okay, please be careful the ratio, and this is called dielectric constant. K is equal to epsilon, K is equal to epsilon, R is equal to epsilon by epsilon naught. And here you can write epsilon is equal to K into epsilon naught. Therefore now this relative permittivity or dielectric constant K having no unit and no dimension, but permittivity having the unit and dimension. Just you go through theory, you can understand, but this relative permittivity having no unit and no dimension. And what are these values? These values are very very important for the problem solving. Therefore now, so its values are, which values are? The dielectric constant values are K is equal to 1 for the free space and K is equal to infinity for metals. Here one point I have to say, what are the metals? All conductors, all metals are nothing but copper, zinc, aluminium, brass, etc, etc, etc. Therefore for all such type of the electric conductors or the metals, K is equal to infinity, and K always greater than 1 for any medium. The dielectric constant or relative permittivity so is always greater than 1. It never than equal to 0. It never be lesser than 0. Means what? K value should not be 0, K value should not be lesser than 1, and K value should not be negative. K value is always greater than 1 or so more than 1. Therefore now these are the values about the dielectric constant. Okay. Now, so now in the CGS system, so in the CGS units, first case what? All Coulomb's law we are expressed in terms of the SI units in the first case. In the second case, now in CGS units, so nothing, just in place of the 1 by 4 pi epsilon naught, just you keep that is equal to 1. In the SI system, its value I have given in the first video, 1 by 4 pi epsilon naught, that is equal to 9 into 10 power 9 into 10 power 9 1. But here, so 1 by 4 pi epsilon naught is equal to 1 when the all quantities, charge, distance, force, if you express them, then the 1 by 4 pi epsilon naught is equal to 1. Now in free space, therefore now once again So if all quantities are expressed in this CGS system, now if the two charges are present in free space, the force F0 is equal to Q1 Q2 by R square. Just in place of the 1 by 4 pi epsilon naught, I have substituted 1. And if the same two charges are placed in a medium, then the force F is equal to 1 by K into Q1 Q2 by R square. Here last point in this discussion is that from about two cases, what two cases? Either in CGS system or in SI system. Now the ratio between the force in medium to the force in a free space, F is equal to F naught by K, a very important relation. And one more important point is that here, so we discussed that K value always greater than 1. When K value is always greater than 1, F naught by K value is going to be decreases. Means what? This denominator is greater than 1. When the denominator is greater than 1, this fraction value is going to be decreases. Means what? You can confirm the force, electric force between any two charges is maximum when these two charges present only in vacuum or free space. Therefore, when the two charges are kept in any medium, the force is going to be decreases. How many times? 1 by K times, because F is equal to F naught by K. We can also write 1 by K into F naught. Therefore, now when the two charges are kept in medium, the force is going to be decreases 1 by K time. Therefore, now electric force is always maximum only in free space. Now let us discuss some other concepts which are related to solve the problems in the objective classes. So now let us consider two charges Q1 and Q2. These two charges are kept in free space with a separation initially R. Now what I am doing that I have taken one material. That material thickness I have taken T, and the material dielectric constant I have taken K. K and T are dielectric constant and thickness of the material. Now when this material is placed partially means what? Only some place it occupies. Therefore, the effective distance between the two charges becomes what? R is equal to R minus T plus T root K. That is the effective distance when this dielectric metal is placed between them. But if this material is placed fully, means what? You are not leaving this gap. Without leaving this gap, if you place completely from first charge to second charge, now just what is that? So T is equal to R. Means what? Here completely it is occupying. It is occupying the total distance between the two charges. Therefore now the thickness is equal to distance, and this thickness is equal to distance you substitute here. Therefore now R minus T, T minus T is equal to 0. Therefore now this part becomes 0. Therefore now the remaining distance R is equal to R into root K. And for any metal, means what? This I told you, this is a dielectric material. But in place of the dielectric material, if you place any metal or conductor, means it may be a copper, zinc or aluminum, etc. Then, so whether it is partially placed, whether it is fully placed, in these two cases, now R is equal to R into infinity, because so R root of infinity, and the root of infinity value infinity into anything infinity. For now, the effective distance between them is always equal to infinity. So please once again keep this point in mind. Therefore, when the two charges are occupied by a conducting material, whether partially or fully, therefore the effective distance becomes the infinity. Now, so after calculating the effective distance, what we need? The electric force between them. Therefore, the new electric force between them is equal to 1 by 4 pi epsilon naught Q1 Q2 by capital R square. This effective distance we have to substitute, not the initial distance between them. Okay, therefore now F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. And the same, so what is the force between the two charges when it is placed by a conducting metal? Therefore now if you substitute R is equal to infinity, therefore something by infinity is equal to 0. Therefore for metals, the force between them is always becomes 0. Now one more concept is, generally this concept will come in the capacitance lesson, that is the second lesson, but it is needed here also. That's why I will explain small part of it. So two spheres are there. First sphere radius R1, second sphere radius R2. First sphere initial charge is Q1, second sphere initial charge is Q2. These two spheres are touching each other, or they are kept in contact through a conducting wire. So when these two spheres are touching each other, are connecting through a conducting wire or metallic wire, then what happens, these two charges will share the charge. Means what? Charge may transfer from first sphere to second sphere, or it may come from second sphere to first sphere due to the potential difference. Sir, what is the potential difference? That is also will come in the second part or second lesson. I will explain there. Therefore, due to this potential difference, the charges will be shared between them. After getting the same potential, means what? The potential of first one, when it is equal to potential of second one, when two potentials are equal, then the charge flow will be stopped. Therefore, after separating the two spheres to their own places, therefore now means what? The first sphere is coming back to its position, second sphere also coming back to its position. Now the new charges are capital Q1 and the new charge on the second sphere I am taking the capital Q2. Now we want what is this capital Q1 and capital Q2 after sharing the charge between them. Now the new charges on two spheres is the charge on the first sphere capital Q1 is equal to R1 by R1 plus R2 into Q1 plus Q2, and the new charge on the second sphere, so Q2 is equal to R2 by R1 plus R2 into Q1 plus Q2. Sometimes they will ask what is the ratio of the shared charges. Therefore now here just you take the Q1 by Q2, therefore near R1 plus R2 cancel, Q1 plus Q2 by Q1 plus Q2 cancel, remaining is only R1 by R2. Therefore now here the two charges in the ratio of Q1 by Q2 is equal to R1 by R2. Then one more question they will ask, that what amount of the charge will be shared. Means what? From first sphere to second sphere, how much charge will be transferred or how much charge will be shared. Therefore that is a difference only. Therefore initial charge is Q1, final charge is Q1 on the first sphere. Therefore now the difference between them is nothing but the shared charge. Capital Q is equal to Q1 minus Q1, that is equal to Q2 minus Q2. Either you can take this one or you can take this one, no problem. Here why I have taken this modulus form means, so you may get this negative charge also. That's why here it is better to keep one modulus form. Therefore this is the one more concept in the Coulomb's law. If two spheres are identical or same size, what is the meaning of identical? Both should have the same radius. Means what? If two spheres are identical or of the same size, under that condition the first sphere radius R1 is equal to R, the second sphere radius R is also R. Therefore now that condition means what? R1 is equal to R2, both have taken R only. Under that condition, what is the new charge? The new charge on the first sphere Q1 is equal to R1 by R1 plus R2 Q1 plus into Q1 plus Q2 already I have given. Therefore now in place of the R1, R2, just you substitute the R value. Therefore R by R plus R. Then by solving R by R plus R is equal to this becomes what? That is equal to 1 by 2 1 by 2. Therefore Q1 plus Q2 by 2. Therefore this is the first new charge on the first sphere. Similarly, by solving this method, you can get the new charge on the second sphere Q2 is equal to also Q1 plus Q2 by 2. If you observe closely, this Q1 value is equal to Q1 plus Q2 by 2 and the Q2 value also Q1 plus Q2. Means that both are sharing the charge equally. So means what? How much first sphere shares, second one also shares the same amount of the charge. So in the second case of the same, means what? In this identical case, one more sub case is that if the second sphere is the uncharged. What is the meaning of the uncharged body? It has no charge at all. Therefore now the second charge Q2 is equal to 0. When second charge Q2 is equal to 0, therefore you substitute here Q2 is equal to 0, Q2 is equal to 0. Therefore now this is the new charge on the first sphere and this is the new charge on the second sphere. Therefore in this case also both spheres share the charge equally. Now let us solve few numerical problems on the Coulomb's law. So now here you see two identical small spheres. First of all, this is a new word. What is the meaning of identical spheres? Both should have the same radius. R1 is equal to R2. So spheres of charge Q and 3Q. First sphere charge Q, second sphere charge is 3Q. At some distance repel with a force F0. Force also given, that is F0. If they touch each other and again placed in same position, means what? These are the two spheres and initial force between them is F0. Both are touching like that and after touching each other, they are placing in the same position. Means what? Initial distance is if you take r, after separating them, the final distance is also r. First observation part. First of all, I am calculating that the initial force between them, F naught is equal to, so 1 by 4 pi epsilon naught. So here first charge Q and second charge 3Q, Q1 into Q2, therefore 3Q into Q, therefore you are getting 3Q square by, for example, distance between them is r square. Like this, you take first sphere and this is the second sphere, and the distance between them, I am taking that is the r, and this is the Q1 and this is the Q2. Let us consider like that. Therefore, this equation, you take equation number 1. So next, after touching each other, means what? This sphere, both are touching like that. And when both are touching like that, we know that charge will be shared from first sphere to second sphere, or second sphere to first sphere. What are the new charges? The new charges. One more point is that for identical, what I told you, for identical spheres, so now you can take that. So what? That R1 is equal to R2 is equal to R. Means what? Both should have the same radius. When both should have the same radius, what is the new charge? The new charge on the first sphere. Means what? When these two spheres are touching each other, the new charge is equal to formula what? R1 by R1 plus R2 into Q1 plus Q2. This is the formula already I have given. Therefore now Q1 is equal to, so R1 R plus R. Therefore now you can get that R by R plus R into, so Q1 and plus Q2, therefore Q plus 3Q, you can get it, and you simplify, you can get that is equal to, you can get that just, that is the 2Q. Means what? So R by R plus 2R, this becomes 1 by 2, this Q plus 3Q, 4Q by 2, nothing but 2Q. Therefore similarly you can get that the second new charge also, you will get the 2Q. Means what? Two charges are getting the same amount. Therefore that means what? After touching each other, they are placing again in the same position. Therefore now the distance between them now also, that is R, and this is capital Q1, this is capital Q2. Why? Because they said, so they placed in the same position. That's why here also I am taking the same distance. Therefore now new force is given by, now new force between them, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. That is equal to 1 by 4 pi epsilon naught. So substitute the values, Q1 Q2 by R square. Q1 value, so that is the 2Q, and Q2 value, that is 2Q. Therefore 2Q into 2Q, you are getting 4Q square by R square. Let us suppose this is equation number 2. Now nothing to do, just you take the ratio of second equation to first equation. When you take the ratio of the second equation to first equation, F by F naught is equal to, you see, 1 by 4 pi epsilon naught, here 1 by 4 pi epsilon naught, both are cancelled. Here R square, both are cancelled. Here Q square, both are cancelled. But here 4 is there, here 3 is there. Therefore you will get that 4 by 3. Therefore the new force, you will get that new force F is equal to 4 by 3 into F naught. This is the final answer. Therefore out of the 4 options, the third option is the correct one. Now let us start second problem. Two charges, Q1 is equal to Q and Q2 is equal to 4Q. And one more request, that if it is not visible, please zoom the video while watching. So with a distance 1 meter, they have given a repel with a force of 36 into 10 power 9 Newton. Force given, distance given, and the charges they have not given. Only just Q and 4Q they have given. But the question what they are demanding, that the number of electrons in second charge are. Means what? In this how many electrons are there? In 4Q charge, how many electrons are present? This is the question. So first of all, I want to calculate this Q value first of all. Therefore from the formula, which formula? From the Coulomb's law formula, F naught or F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the formula, we know that. Substitute the values. F is equal to what? That is equal to 36 into 10 power 9 Newton. That is equal to 1 by 4 pi epsilon naught. That is equal to 9 into 10 power 9 into Q1 is equal to Q. Q2 is equal to 4Q. 4Q into Q, 4Q square. Therefore now 4Q square by, so distance R is equal to, they have given 1 meter. Therefore now 1 whole square. And if you simplify it, you see, therefore 36 into 10 power 9 is equal to, here 9 4s are 36, so 36 into 10 power 9, so here, so into 4 Q square only remaining. That is, now here 36, that 9s are 36 and these are cancelled. Therefore now you are getting that what? Q square is equal to 1. Of course, Q is equal to plus or minus 1. You can take plus or minus 1, but I am taking that. Therefore now here Q is equal to 1 I have taken. But right, this is the Q value. Sorry, Q is equal to 1 Coulomb or 1, we got it the answer. But what the question is, the number of electrons in second charge. Therefore, what the second charge? Now the second charge is the second charge. So now Q2 is equal to 4Q. Therefore now that Q2 is equal to, you can get that 4 into 1, that is nothing but the 4 Coulomb. Therefore in 4 coulombs how many electrons are present, we have to calculate. So from the formula already we know that in the first video we have discussed the quantization principle, that is so Q is equal to N into E. This formula I have given already. Therefore now here from this what, N is equal to, so now Q by E, and in place of the Q2, that is equal to what? That is equal to 4 by E value how much? 1.6 into 10 power minus 19. If you simplify it, N is equal to, now this, so here I am writing 4 as it is, so this 1 by 1.6 into 10 power plus 19 I am writing. Why? Because 10 power minus 19 goes up, it becomes the 10 power 19. From this, here I am writing this is the 10, and just here I am writing that is the 10 power 18. So now 10 by 1.6 becomes the 6.25. Therefore now here N is equal to 4 into 6.25 into 10 power 18. Therefore now 4 into 6.25, nothing but the 25. Therefore N is equal to 25 into 10 power 18. This is the number of electrons in the second charge. Therefore now out of the 4 options, option B is the correct answer. Now, so these 2 problems for your work at home. The 2 problems are, the force between 2 charges is F. If the distance becomes off and each charge also becomes off, the new force is. I hope all of you understand the question. Distance and each charge, they are made off. Then the, what is the new force? First option, second option, third option, fourth option, solve it. Second question, somewhat interesting and thinkable question. So the force between 2 charges is 100 Newton. They have given that is 100 Newton. If one charge increases by 10% and other charge decreases by 10% with the same distance, then the new force is what? All of you think that, sir, here first charge decreases 10%. At the same time, second charge decreases by 10%. All of you guys, what you will think I know. But I want the answer. Please all of you solve it. Now the answers are remaining the same. And second option 99 Newton. Third option 101 Newton. Fourth option 110 Newton. All of you solve it. And good luck.